Chapter 7 conclusion. 7.7. Chapter 6 began with a concern in the regression of test scores against the student-teacher ratio, omitted student characteristics that influence test scores might be correlated with the student-teacher ratio in the district, and if so, the student-teacher ratio in the district would pick up the effort on test scores, pick up the effect on test scores of these omitted student characteristics. Thus, the ordinary least squares estimator would have omitted variable bias. To mitigate this potential omitted variable bias, we augmented the regression by including variables that control for various student characteristics, the percentage of English learners, and two measures of student economic background. Doing so cuts the estimated effect of a unit change in the student-teacher ratio in half, although it remains possible to reject the null hypothesis that the population effect on test scores, holding these control variables constant, is 0 at the 5% significant level. Because they eliminate omitted variable bias arising from these student characteristics, these multiple regression estimates, hypothesis tests, and confidence intervals are much more useful for advising the superintendent than are the single regressor estimates of chapters 4 and 5. The analysis in this and the preceding chapter has presumed that the population regression function is linear in the regressors. That is, that the conditional expectation of big Y sub I given the regressors is a straight line. There is, however, no particular reason to think this is so. In fact, the effect of reducing the student-teacher ratio might be quite different in districts with large classes than in districts that already have small classes. If so, the population regression line is not linear in the axis, the big axis, but rather is a nonlinear function of the big axis. To extend our analysis to regression functions that are nonlinear in the big axis, however, we need the tools developed in the next chapter. Summary. Number 1. Hypothesis tests and confidence intervals for a single regression coefficient are carried out using essentially the same procedures used in the one variable linear regression model of chapter 5. For example, a 95% confidence interval for beta sub 1 is given by beta sub 1 hat plus or minus 1.96 standard errors of beta sub 1 hat. Number 2, hypotheses involving more than one restriction on the coefficients are called joint hypotheses. Joint hypotheses can be tested using an big F statistic. Number 3, regression specification proceeds by first determining a base specification chosen to address concerns about omitted variable bias. The base specification can be modified by including additional regressors that control for other potential sources of omitted variable bias. Simply choosing